Hello, my dear learners. It's me, Teacher Lawrence, once again. In our last video, we discussed about the basics of the student's t-distribution. We identified it as having almost the same bell curve as that of the normal distribution, just a bit shorter and heavier by the tails. We also discussed that ideally, we use t-distribution if the sample size is relatively small, that is, it is less than 30, and the population standard deviation is unknown. Subsequently, as the sample size increases, the curve becomes more and more like the normal distribution. We use t-distribution in conjunction with t-test to estimate significance and confirming or denying the null hypothesis. We use the following formula to find the t-value or the t-score. This formula, however, when manipulated algebraically, will produce another formula to determine the confidence interval in estimating the population mean. So today, we're going to deal with the confidence interval for population mean with unknown population standard deviation. Here are the objectives for today's lesson. Identify the appropriate form of the confidence interval estimator for the population mean when the population standard deviation is unknown. Solve problems involving confidence interval of the population mean. Draws conclusion about the population mean based on its confidence interval estimate. Now, here's a worded problem. The average volume of 10 randomly selected water containers in a certain factory was found to be 10.5 liters with a standard deviation of 0.352. Determine the margin of error for the population mean, and B. Find a 95% confidence interval for the population mean. Now, before we even solve for A and B, let's determine first if we're going to use the normal distribution or the t-distribution. In our worded problem, the sample size is equal to 10, and that is obviously less than 30. Now, is the population standard deviation known? It is stated here that the standard deviation is 0.352. Question is this the population standard deviation? This problem describes the data of only 10 samples out of thousands or even millions of water containers. This only means that the standard deviation being mentioned here is that of the sample and not of the population standard deviation. Therefore, the population standard deviation is unknown. In that case, we will be using the t-distribution. Now, let's rewrite our worded problem in our Blackboard. B. Okay. First thing we need to do is to write down what we know. We know that the sample size is equal to 10. The sample mean is equal to 10.5 and the sample standard deviation is 0.350. Now let's put them aside. In order to answer letters A and B, we will be needing this formula. The confidence interval for the population mean mu is going to be within x bar plus minus t-value or t-score times the sample standard deviation over the square root of n. This section here is the formula for our margin of error or EBM. EBM stands for error bound for a population mean. Now we cannot yet compute for the margin of error simply because we still don't have the value for our t. T has a subscript df for degrees of freedom, comma alpha. You've already learned that the degrees of freedom is computed as n minus 1. The value for n is 10, so 10 minus 1 is equal to 9. Now, the next thing we're going to do is to compute for the value of our one-tailed alpha. We sometimes read it as alpha half, and its formula is equal to 1 minus confidence level divided by 2. Now the confidence level is 95%, which you can find here. But as a decimal, if you're going to divide it by 100, it's going to be 0.95. So 1 minus 0.95 is equal to 0.05. And if you're going to divide it by 2, that's going to be 0.025. Substitute that now to our symbol. And now we can determine the t-value using our t table. The degrees of freedom are located at the left side of the table. The value for our degrees of freedom is 9, which is located here. On the other hand, our alpha, which is 0.25, which is one-tailed, is located here. The intersection of the two will give us our t-value, which is in this case 2.262. So we'll add this now to our known data and proceed to the next. Now that we have our t-value, we can now proceed determining the margin of error or EBM. The formula for the margin of error is t times the sample standard deviation over the square root of n. So we'll already have the values for t, s, and n. Substitute the values for the formula, and this is how it's going to be. 2.262 times 0.352 divided by the square root of 10 is equal to 0.2517 or 0.25. This will now be our answer for letter A. Moving on to letter B, find a 95% confidence interval for the population mean. We can rewrite our formula into something like this. 95% confidence interval is within x bar minus EBM, comma x bar plus EBM. X bar minus EBM represent the lower limit, while the x bar plus EBM represent the upper limit. Our x bar is 10.5 while our EBM is 0.25. Substitute the values for each symbols and we'll have this. So we have 10.5 minus 0.25 comma 10.5 plus 0.25. And the final answer would be 10.25 comma 10.75. This will now be our answer for letter B. But it doesn't end there. Okay, so if what now that we know the lower and the upper limit? What does this mean? Okay. So this means that we are 95% confident that the average volume of all the water containers in the factory is somewhere between 10.25 and 10.75. Right. So that is how can determine the confidence interval for the population. Yeah. Okay, so that is 10.25 and 10.7. Now, let's have another example, this time a bit harder. The following are randomly selected scores in Filipino of 12 grade 10 students, containing the following scores. So we have 75, 65, 76, 80, 85, 77, 81, 83, 80, 70, 71, and 69. Find a 99% confidence interval for the mean score of all grade 10 students, assuming that the student's score is normally distributed. Question: can we use the D distribution here? The sample size is equal to 12. That's less than 30. Check. Now, is there an indicated value for the population standard deviation? There is none, which means therefore that we can use the t distribution. Now, aside from unknown population standard deviation, the sample mean and the sample standard deviation are also unknown. But no worries because we'll be able to determine those using this data. Now back to our drawing board. Okay, so here is again our worded problem. We write down first what we know, and there's only one thing that we know, and that is the value of our sample size n. Now the first step in this case is to find the sample mean and sample standard deviation. To do that, we will be needing this table. The sample size are the number of randomly selected students labeled 1 to 12 with their corresponding scores. The formula in getting the sample mean is this. X bar is equal to the summation of x divided by sample size n. We know already the value of our n, which is 12. To get the value for the sum of x, all we need to do is to add all these numbers from 75 to 69, and the result is 912. Substitute the values for its corresponding symbol, and this is how we will write it. 912 divided by 12 is equal to 76. That will be the value for our sample mean. The next thing to do is to fill up the blank rows for the third column. We simply subtract the value of our sample mean to the values of x. The first value of x is 75. So 75 minus 76 is equal to negative 1. So that is what we will place on the third column. The next value of x is 65 minus 76 is equal to negative 11. Then we will write it down again. We'll do the same process for the next value of x up to the last. So that is how it's going to be. The fourth column is simply getting the square of the result we had on the third column, particularly these values. So if we are going to get the square of negative 1, the result is equal to 1. Getting the square of a number is simply multiplying the number by itself, such as 1 times 1, 6 times 6, negative 1 times negative 1. When you square a number with a negative sign, the result is positive. Moving on to the next value, the square of negative 11 or negative 11 times negative 11 is equal to 121. Do the same process for the next value. We have the square of 0. Of course, that is 0. Then the square of 4 is 16. And so on. Just like what we did in our second column, get the sum of all the numbers on the fourth column, and the result is 420. We can now compute for the sample standard deviation. We will be using this formula wherein S is equal to the square root of the sum of quantity x minus x bar squared divided by n minus 1. The value of our enumerator here is the one that we got here, which is 420. Substitute the values and it will look like this. Square root of 420 divided by 11, the result is square root of 38.18. And finally, our sample standard deviation is equal to 6.18. Alright, so now that we've got our trio, we can now proceed with the usual process of getting the confidence interval. Let's start with the t-value. We need to find the degrees of freedom, then the one-tailed alpha. The degrees of freedom is equal to n minus 1, so that's 12 minus 1, which is equal to 11. Substitute. Next, find the alpha half, that is 1 minus the confidence level over 2. The confidence level can be found here, which is 99%. That's 0.99 when converted into decimal. So 1 minus 0.99 divided by 2 is equal to 0.005. Substitute. And now let's bring out our t table. The degrees of freedom is 11, which is located here, and our one-tailed alpha is located here. Go to the intersection, and there you will find our t value, which is 3.106. Now, for the margin of error, we already have our values for t, then s, and n. Substitute that in our formula, and we have this. EBM is equal to 3.106 times 6.18 divided by the square root of 12. The result is 5.54. Right. Next, rewrite our formula to reflect the lower and upper limits. This is the value for our sample mean and the value for our EBM. Apply those to our formula, and the result will be 70.46 for our lower limit and 81.54 for our upper limit. And what does it mean? It means that we are 99% confident that the average score in Filipino of all grade 10 students is somewhere between 70.46 and 81.54. Okay, ready to try it out your own? Here's one for you. The average weight of 20 randomly selected students in Ilocos National High School was found to be 165 pounds, with a standard deviation of 4.5. Find a 95% confidence interval for the population mean, assuming that the student's weight is normally distributed. Now, pause this video and try to solve it on your own. When you're done, just resume this video to see if you got the correct answer. Okay, you're done? Okay, if your answer is like this, then you've got the correct answer. And if you've interpreted it like this, then you are correct as well. Good job. Okay, now just a recap of what you've learned. We use t-distribution in getting the confidence interval for the population mean if sample size is less than 30 and that the population standard deviation is unknown. To get the value of t, simply find the degrees of freedom and the one-tailed alpha, and the intersection of the two will give you the result. The margin of error, represented by the EBM, is the result of multiplying the t value to the sample standard deviation over the square root of the sample size n. And finally, the formula in getting the confidence interval, which we can rewrite to the following to reflect the lower limit and the upper limit of the population mean. I hope I gave you an informative lesson in getting the confidence interval for the population mean using t. Thank you for listening, and until the next lesson. Bye.